Hello and welcome to the second part of this Flappy Bird tutorial series. So this second part is going to show how to make pipes, just like in Flappy Bird, that they're going to have a variable height and they're going to start on the right side of the screen, move across past the player. When they're off screen, they're going to loop back around to the other side. So just go ahead and start off by opening the Flappy Chicken level, and we're going to just start off by going over somewhere to the right where the player can't see when the game's running, so preferably off camera, but try to keep it the same X value as the player. So currently the player's at 60.5. I'm just going to make that 50, and I'm going to make his Y just be 70, just for easiness, and then I'm going to make the camera be like 60, and make that also be 70. So okay, so the player's centered on the screen. That's cool. Let's go over here and create new component entity. And we're just going to make sure that that's set at 50, and we're going to put that like 80 or something. And 32 is fine in the Z. We're going to name this pipe, and we're not going to do anything else. So we're going to create entity as child, and we're going to name this bottom pipe. And bottom pipe is going to get a rendering static mesh, which is click on this ellipse here, and if you look in the objects primitives, you'll find this post to 0.4 times 0.6 and then 0.5 times 0.5. I'm going with the 0.4, 0.6 because it's a little more pipey looking, and the material is just kind of this default material that it even tells you to replace it. So I'm going to go in here, and in the materials folder, getting started materials, I'll just give it like green box sample because it's a pipe. Alright, and the other thing I'm going to do here is change the Z to 2 just to make it a little bit bigger. And then I'm going to duplicate it, name this one top pipe, and move it up so there's like a 1 or 2 gap in there, because this is the gap the pipe is going to be moving across the screen like this. So we want to make sure that the player has enough space to actually jump, or else it's kind of not fair. So these can both be children of pipe. And really, that's all we have to do to just visually make it look like that. The other thing we're going to do is start the scripting. Before we actually make a flow graph, though, I'm going to go in here and about like right here, I'm not going to create a new component entity. I'm actually going to go to the roll-up bar, AI, and put a tag point. And the tag point, I'm just going to leave it at 32 and try to make sure that it's the same X, but I'm going to actually put it on a little bit in front because this is going to be the starting point. So the pipe is going to start here and then move across. So I don't really want to put it like this, or else it's just sort of annoying to deal with when I'm using it for the script. So I'm going to keep that selected, but I'm going to right click pipe and go flow graph, add, name this something like pipe mover. Now this is going to be a pretty complicated script here because we're going to be doing everything that makes the pipe move and then loop back around in one flow graph. So take a deep breath. Alright, let's do this. So we're going to start with a start node, a math set number node, a logic any node, and 2 movement move entity 2 nodes. So first thing pretty much always to do is make sure choose entity is, most of the time it's going to be graph entity, sometimes it might not be graph entity, so you just have to kind of be careful with that. Game starts, kind of obvious, this just goes when the game starts. We're going to just right off the bat, that's going to go to activate and in 0. Now set number, this is basically like just a variable, turns it into a float number, and we want this to be greater than 0 because value, is how fast the object will move when it goes to this moved entity 2 node. So value is 0, it doesn't move. So I'm going to turn it something like 3, and then out is going to go to this value and this value. And before I get ahead of myself, I'm actually going to delete this and add a time delay node. And this is just whatever delay, this is seconds, and this is just start the game. It'll be 1 second currently, and then the pipe will start. It's not really necessary right now, but it will be necessary later on when we have more than one pipe moving. This is just for spacing, so we might as well set it up now. And then this logic any out is going to go to start, and then here's the thing that's kind of weird. There's 2 move entity 2s. It would be nice to only do it with 1, but you can't make a finish go to start. It just doesn't let you do it. So we're going to finish is going to go to this logic any, which is going to go to start, and this finish is going to go to that start. So it's going to game start, set this number to 3, delay for a second, and then it's going to go through this thing, out to start. This is going to move at speed of 3. When it finishes, it's going to immediately start this one. And when this one finishes, it's going to go start this one. So it's basically just going to be forever looping between these 2 move entity 2 nodes. Now currently it's not really going to work very well because you can see it's going towards 0, 0, 0. And we don't want that, obviously, because this destination has not been filled out yet. So we're going to have to do another, pretty much a whole nother half of this, and this is going to be some vector math. So this side we need another logic any. Now the reason we need a logic any is because if you'll notice here, if we didn't have this logic any node and we just went out to start and then finish to start, it doesn't let you do both. So that's where the logic any comes in. So we go like that, and then that goes to start. So that way we can basically take 2 outputs and turn it into 1 input. So we need this logic any. We're going to go finish, finish, and then the game start output to into. The other nodes we're going to need here is a math random vec3 to vec3 vec3 add vec3, and we're going to need 2 of those. We're going to need a component entity dot transform component set entity position node, and this is kind of weird, we're going to need the tag point. So we see we currently don't have the tag point selected, so select it and go here and go right click, add selected entity. Now it might add an entity ID node. If you get that, just delete it. We don't really need it. This is all we need. So the first thing we're going to do here is go this logic, which is going from both finishes and output. So don't make sure that it's not, don't delete this one and only go to that. Also go to that. So both of these outputs also go to logic any in addition to going to the start of the other ones. Logic out goes to math generate, and this is going to be -5 because this is going to be basically the range of which our pipe will move. So if we look at it here, right now it's at 32, -1, 2, 3, 4, 5. That's a little bit too far, so 5, 6. So we don't want it to be greater than 0, or else it will raise the pipe up above the ground. Now out is a float, and out rounded is going to be an integer. Integers are just look nicer, or else the pipe you can barely tell the difference of its height. So that's going to go to the z. Now result is going to go to activate and b of one of the add vec3 nodes. So add vec3 is just going to take vector a and vector b and add them together. In this case, the output vector to vec3 is 0, 0, and then somewhere between -5 and 0 in the z. And the other one is going to be the position of the tag point. So this is the tag point plus a variable in the z, which is what we want because we're going to activate new position, and of course make sure that this says graph entity. Make sure this down here says tag point, make sure that says graph entity. And the reason we're going to do this is because the first thing that we want to do is output. It's going to go any generate a random z, create a new vector at the starting point, and then it's going to put the pipe at the new position, which is going to be the starting position. And we want to do that every single time, which is why we also have it when it finishes here. However, we also need this output to go to that, activate, and A, and the B, this is a negative in the Y, whatever is going to make it go far enough to go off screen. So negative 30 will probably do that. And this is just, the pipe is going to start here and it's going to go negative in the Y, however many we gave it. So if we started at 80, negative 30 would be right there. So we're actually a little bit too close, so I'm actually going to just put this up to 90, and I'm going to make this be 85, just so it doesn't show up on screen when it's doing this loopy stuff. Also, sometimes your pipes, they might not be visibly in there. Bizarre. And now this out is going to go to both destinations, because these are actually exactly the same move. We just need two because of quirks in the flow graph system. So that's actually it. That's the complete flow graph for the pipes. If we save, and I'm just going to remove the camera in the entity inspector just so we don't have to wait for it to appear on screen. So if you saw what happened there, I tried to play and the graph entity just, or the pipe just is gone. And the reason why is because if you go back into your flow graph, this tag point here got set to graph entity, which we do not want. We want that to say tag point because that's pulling the position from the entity and it's pulling the position from graph entity, and we don't want that. So just make sure that says tag point right there. Alright, now if we play, so it took about a second, but we can see that it's looping. And then when it gets to what negative 30 is, it's going back. And you can see that every time it does that, it's going to have a slightly different Z, which is exactly how Flappy Bird works. So that's pretty cool. Now you'll notice that there's no collision happening with the player, and that's fine because we're going to do that in the next episode. And of course there's only one pipe because we're going to do all the collision stuff first, and then we're going to duplicate it so there'll be more than one pipe on screen. So I'm going to just put the camera back and play. You can see that the pipe started a little bit too soon, so I'm just going to move it back one or two pieces. And now you can see that the pipe appears off screen. If you don't like the speed, you can always change it, of course. And you can see it actually didn't quite go far enough in that case. So go back here, maybe make this like 35 or something. And if you want to change the value, see the reason the set number is here is if you didn't have set number, you would have to change value here, 3, and value here, 3. And then if you wanted to change it, you would have to value 4 here, value 4 here. So you'd have to change that every single time, which is just awful and inefficient. So if you put the set number in there, you just have to change it right there. Now the pipe should be moving a lot faster. And it goes all the way off screen, and then it loops back around. So everything's working as intended, and this will lead nicely into the next episode, which will be about how to make the pipes actually collide with the player. So thank you for watching, and I hope that was useful.